So, we were discussing about the starting torque of a single phase induction motor having an auxiliary winding, and we got the starting torque to be is equal to, in synchronous watt, it is equal to R2 dash. There was 2 1 no? Just 2 R2 dash Im Ia sin theta into a term A is Nm by Na. If there is a number of turns difference, you have to incorporate that factor also. Now, this is the starting torque, and we conclude that theta is the angle between Im and Ia. Between these two phasors, this angle, and everything is s equal to 1, standstill condition. Now, the point is, suppose I have decided to use a resistor split motor, resistor split phase motors. Okay. That means, this is the rotor. In the auxiliary winding, I will connect an external resistance R external, and main winding I will not disturb. Okay. So, these two we are connected in parallel and connected across a supply, fixed supply, AC supply. So, this is Im and this is Ia. Okay. So, in general it will be like this. This is your supply voltage, your Im let Zm bar is the impedance here, and it is Z bar impedance offered to the supply at starting. So, V by Zm bar will be Z bar m will be the current here, and this will be theta m, and theta I bar A will be somewhere here, perhaps I bar A, and this is theta A. Because it is more resistive compared to main winding, current will be there, magnitude may be different, and this angle is important. This is theta, that is to be used here. Now, therefore, I want to select a optimum value of R external, auxiliary winding resistance, so that starting torque I want to maximize. Now, to find out that, obviously you now know that what I have to do is this: I have to find out the locus of I bar A as I vary resistance in the auxiliary winding. So, auxiliary winding Z A bar is after all inductive, R L will be there always, and therefore, if you vary the resistance, the locus of the tip of the circle of I A bar will lie on a circle, and we know what is to be done. Therefore, as auxiliary winding resistance R auxiliary now becomes equal to R auxiliary inherent, that I cannot change, inherent resistance plus this R external, whatever I have done. I can vary this R external, but anyway, the thing is that this is suppose your supply voltage phasor, then your locus of the tip of IA, locus of tip of IA phasor will be a circle, What will be the diameter of the circle? When this whole r is 0, it will be V by x a, and at that time the current will be lagging, therefore, it will be like this, is it? So, it will be something like this, because lagging it cannot. What is this? This is V by x a, total inductive reactance, which I am not changing. This will be there. This is the center of the circle. So, I can draw this circle. It is the IA. However, IM will be fixed. IM will be fixed. IM cannot change. ZM is fixed. Decided by running condition thing. I will not change. So, this will be your theta m. Okay. Now, I will draw the IA phasor. Suppose IA phasor, since resistance is higher, it will be somewhere here, I do not know. This is I bar A, arbitrary position for some value of R external, it will be here, and this angle will be theta A. Mind you, and this angle is theta. Therefore, torque will be maximum, T starting torque, which is equal to 2 R2 dashed A Im Ia sin theta. To maximize torque, to maximize TST, other things remaining same, Ia sin theta should be maximized. Sin theta should be maximized. Now, the question is, what is Ia sin theta? Ia sin theta is nothing but this length, drop a perpendicular to Im axis. This is Ia sin theta. If you have chosen arbitrarily, okay, this length is to be maximized. Now, the question is where this point should be, so that this intercept Ia sin theta will be maximum. It will be maximum provided this line passes through the center of the circle. That is, you draw a line perpendicular to this Im line, wherever it touches, if your Ia, position of Ia for maximum torque. This is the position of Ia when R is arbitrarily chosen, when Ra has some arbitrary value. In other words, what I am telling, this should be the position of IA for maximum torque, because it is this intercept which is to be maximized, and that is this length will be maximum when if you drop a perpendicular from this point to IM axis and that passes through the center. That is the whole idea. Therefore, this simple geometry rule can be found out in this way. So, I will draw this characteristics for maximum position only V bar m, and first I will draw the circle. This is suppose the center, and IM is suppose here, this is IM, and you drop a 90 degree there to this arc, 90 degree wherever it cuts this circle, there you say this is your IA. What is the diameter of the circle? B by XA. Anyway, so this angle is theta A we are looking for, and this angle is theta M. And this angle is theta, and then this length will be maximized. Although the circle is not drawn very good, I mean what I mean to say, if I join these 2 points, this will be also theta? No. This is, you know, this rule, if you have a circle and if you have a tangent here, this angle is always equal to this angle. Therefore, here it is a tangent there, and here is a triangle whose tips are like this. So, this should be also theta A, because this is a tangent, this is a circle. So, this angle theta A must be the internal opposite angle theta A because of this.
If the tangent is parallel to the base of the triangle.
No, not necessarily. It could be anything. This angle will, it can be easily shown, because angle on a chord are always same, no matter where it is. In a circle on a definite chord, all the angles subtended are same. Therefore, if it is theta A, this has to be theta A. I will not go to that level right now. So this is the thing, and theta is theta m minus theta A. Therefore, it looks like that, and then this angle theta m minus theta A must be equal to theta A. These 2 angles are same because it is a chord and it passes through the origin, bisects. So, it is a I mean these 2 sides are equal, and then or 2 theta A is equal to theta M. In fact, we are done. Now, what I am telling is this: if you have a calculator, you know Zm, suppose Zm value is known, Zm theta m. So, this value is theta m is known. Suppose the parameter values, impedance offered to the supply by the main winding is known completely, then theta m is known. If theta m is known, I will say I know theta A. which is theta m by 2, and then I will say tan theta a is equal to x a divided by R A inherent plus R external, and this is now known this side because theta A is known, and then from this I will be able to get R external. That can be done graphically. You just simply Zm is known, this relation is known, I will calculate theta A and tell tan theta A is nothing but reactance of auxiliary binding divided by this plus this, from which I will be able to calculate R external and say that will be the value of R external chosen, and then with that R external you calculate I A and use that torque expression, that is R2 T is equal to 2 R2 dash A I m I A into sin theta. Theta m theta a are known, but I will go just a step further, and only for this one I will do, because see, the moment you get this tan theta a, we have got this relation. Some earlier books when computations were difficult, you have got this one theta m is equal to 2 theta a. You have got. Therefore, it can be written as theta a is equal to theta m by 2, is not? So, tan theta a, this is, I do not know whether it will come like that. Is it equal to sin theta m by say 1 plus cos theta m, because this is 2 sin theta m by 2 cos theta m by 2 numerator, and denominator is 2 cos square theta m by 2. So, this cancels, this is indeed tan theta m by 2. So, this is nothing but tan theta m by 2, is not? So, it is actually what I am doing is this tan theta, take tan of both sides, tan of theta m by 2, and then tan theta m by 2 can be written like this. I mean, trying to get a closed form expression for that R A external instead of going graphical. So, tan theta is this. Then I will say or x A divided by R inherent auxiliary winding resistance plus R external optimum must be equal to sin theta m is nothing but x m by z m, and this is 1 plus R m by z m, and which is equal to, these are pure mathematics, x m by z m plus R m here, or you can write R A plus R external. I mean, do not memorize this, I am telling you, although I am doing, it is no point. R A plus R m is x A plus z m plus R m divided by x m. I mean, some people multiply with z m minus R m, or do whatever you like, but then R external can be found out because R A is known inherent. So, this is how this can be found out. I am also not finding out, for example, maximum torque will be this length proportional to I A sin theta. I mean, one can find out also expressions like this, but this you see. I will send you a note where you can find these things. But the whole idea is this, that you try to find out the angle of the auxiliary winding by using the concept of circle diagram and fix up the point. Okay. Now, after resistor split I have done, but resistor split what happens is this, the starting torque, well, it will be maximum. If somebody sticks to resistor split, what best he can do is to choose this value of R external, but the starting torque obtained will be in compared to capacitor start split motors, split phase motor, will be much less. And so people, this is only little bit of starting torque compared to capacitor split phase motor is obtained. Now, let us see what happens to capacitor split phase motor. How to, so capacitor split phase motor. Capacitor starts, starting torque, starting value of optimum capacitor, optimum starting, I think optimum should be here, starting optimum value of capacitor. Okay. How to do it? In same way I will do. What is the thing now? Thing is, it is better you draw this circuit. Here you are connecting an XC and here is your rotor, here is your main winding. Instead of R external, now some capacitance, and here is these two are in parallel, and here is the supply V bar, this current is I bar M, and this current is I bar A for a arbitrarily chosen XC, such that this IA bar will lead I bar M. I will choose such a value of capacitance. So, this capacitance value must be at least greater than inherent impedance. What is the inherent impedance? This is having RA plus JXA. RA plus JXA, this impedance I cannot do anything. RA plus JXA is the inherent auxiliary winding impedance, all at the time of starting auxiliary winding impedance. After you connect this XC, after XC is connected, our ZA will become RA plus JXA is there minus JXC. Is not, that will be the total impedance. I am telling if you make XC greater than XA, it will become capacitive, current will be leading starting. So, it is this fellow I am varying. Okay. Now, that is IM remains fixed, as I am telling repeatedly. Now, what I will do is this, I will draw once again the circle diagram. Suppose this is your supply voltage, like this. Then the circle diagram will be, oh my God, like this. Okay. This will be the locus of the tip of circle diagram. Why I have shown two halves? Because when Xc is 0, this circuit will be inductive. See, this is the circle diagram. If you have X here, which is varying reactance. It could be inductive as well as capacitive. So, for the whole range of variation of x, this is the circle diagram. Okay, that is fine. Then your I m will be lagging this, and that angle is fixed. Oh, this time I have drawn V vertical. It does not matter, drawn horizontal or what. So, this is theta m. And depending upon this value of x, the position of this one will be varied. X equal to 0 will be somewhere here, lagging power factor, x 0. But x greater than x the current will be here. That is what I want to tell. And this is the center of the circle, Therefore, for large value of x or whatever it is, some arbitrary value of x suppose this is I a. I have drawn I a this much, do not worry about that, it is about the scale. It will be less perhaps, but the angle is important. Here this will be then theta a. It is for arbitrary value of x c, but arbitrary value x c greater than x a I have chosen because leading current, it is like this. So, what I have to do to, so what will be the torque now produced? Torque is proportional to I a sin theta, I a into sin theta. Therefore, from the tip, oh I am sorry, I cannot play with this length, it has to be here. I a, tip of I a lies on the circle, I am of course fixed theta m. So, I a is this one, the length, and I a sin theta means I have to drop a perpendicular from this point to I m axis. So, I will drop. And then this will be equal to your I a sin theta, and this I a sin theta I m will be proportional to the torque. It is for any arbitrary value of x c. Now, the question is where this point should be, so that I a sin theta will be maximum. It will be once again, it should be somewhere here, you drop a perpendicular passing through the center, and this should be the position for I a for maximum torque, position of I a for maximum torque, for T starting maximum, is not just like that resistance one, position of maximum torque, I a sin theta to be maximized. Then through the center you drop a perpendicular to the chord I m, to this length I m, and it will be there. So, what should be then the relation? So, now I will draw only for this maximum torque. So, yeah, first I will draw the circle. This is the thing. This is my V, and this is your I m. I m need not lie on this circle, and this is suppose the center of the circle. So, drop a perpendicular there 90 degree, wherever it means that should be then your I a. This should be your IA. Now, what are the things I know? This is theta m and this is theta a. This will be the thing, and it is a right angle triangle. And since this is centered, it is a chord. So, this will be also theta a, is it not? Theta a, because these two are radius. So, what is the condition from this right angle triangle? Theta a plus theta m must be 90 degree, because this is 90 degree. Therefore, the condition is theta a plus theta a plus theta m is equal to 90 degree, or 2 theta a is equal to 90 minus theta m. This is the thing. This will be got the point. Now, so I will be, if with the help of if Zm is known, then theta m is known, then 2 theta a is known, then theta a is known. Then I will say it is known, then I will say tan theta a. Here you should be a bit careful. It is equal to Xc minus inherent auxiliary winding resistance X by R by inherent. This time I am not connecting any external resistance, only capacitance. This value is known then, from which Xc can be calculated. I leave it to you to find out, in like the previous one, a closed form solution of Xc by playing with this equation. Clear? So, you take tan of both sides or things like that and try to find out. So, today I stop. So, we have discussed in this class very important topics, that okay, for starting you have to do some phase splitting, and the starting value of the capacitor. If it is a capacitor split phase motor, we have discussed, provided you know Z bar m, you can ultimately find out theta a after constructing this phasor diagram, and the whole thing is this length is to be maximum, not I s sin theta. So, merely telling theta I will make 90 degree will not guarantee you maximum starting torque in most of the cases. Similarly, for resistor split phase motor. Okay, thank you.